The James Webb Space Telescope has revolutionized the world of astronomy forever. With its unmatched capabilities, it has provided valuable information that reveals the secrets of distant galaxies, stars, and even the origins of the universe itself. The James Webb Space Telescope has recently made another exciting revelation. It has discovered a vast system that is older than the universe itself. Yes, you heard that right. This unique discovery has created a buzz of excitement and curiosity among scientists around the world. But the question is, how could anything even exist before the universe came into existence? We're talking about a system that blows away all our previous ideas about the origin of everything.
Infrared light is sent out by objects that are too cool to emit visible light. Things that are very, very far away, like the earliest galaxies, they send out visible.
The significance of this discovery is huge, and it made us question the basic laws of the universe. This new system is estimated to be 13.8 billion years old or more. According to scientists, it seems to have evolved even before the Big Bang. So, what exactly does this discovery mean for our understanding of the universe? Well, it raises several intriguing questions. One possibility is that this structure originated in a previous universe, or a different dimension altogether. If this hypothesis is proven, it would have profound implications for our understanding of multiverse theories and the nature of reality. The most accurate models like lambda cold dark matter, CDM, and the conventional model of cosmology were unprepared for what James Webb discovered. In other words, Webb's discoveries could fundamentally alter our view of the Big Bang and the history of the galaxy. To understand how the JWST discovered something that existed even before our universe, we have to understand what this system actually is. This system is not a black hole, galaxy, or nebula. This celestial body is named HD 140283. It is basically a star that challenges our understanding of the universe and holds the very key to unlocking the mysteries of space and time. Located around 200 light-years from our planet, this celestial wonder defied all expectations, earning it the nickname Methuselah star for its incredible age. Believe it or not, HD 140283 is a 14.5 billion year old wonder, making it one of the oldest known stars in the universe. Its existence predates our own Milky Way galaxy by a staggering 1.7 billion years, forcing us to reconsider the very timeline of our cosmic history. When astronomers dug deeper into its mysteries, they could not believe that this system defied conventional astrology. HD 140283 is not just a divine spectacle, it is a cosmic time capsule, which unlocked the mysteries of our universe's youth and inspired astronomers to push the limits of exploration. Initially, when scientists began space exploration, all that was visible were the individual stars clusters and proto-galaxies, which would only exist in small numbers and have a completely blue and primary look. The farther away in time we go, we will see ancient stars and their clusters, along with the fact that there shouldn't be any more vibrant sources visible to us, other than the leftovers from the Big Bang. When we are looking into such celestial objects, we are essentially asking the universe, how did you grow up and become who you are today? The James Webb Space Telescope is developed with high-resolution and high-sensitivity instruments, which allow it to view objects too old, distant, or faint for the Hubble Space Telescope. By analysing distant celestial bodies, we can verify whether our comprehension of the universe aligns with the truth. JWST's most clinical contribution lies in its abilities to study galaxies that exist at immeasurable distances that even seeing them closely seems like you've travelled back in time. With each discovery, the James Webb Space Telescope propels us into the beyond, unveiling phenomena that faded a long time ago. The James Webb Space Telescope possesses a remarkable ability to detect remote galaxies and capture images and videos in the infrared wavelength. Before the JWST, only a few of these distant galaxies have been seen using the Hubble Space Telescope, which observes the universe correctly but only captures things that humans can understand. However, as the universe grows, the galaxies are moving farther away from us, and with time, it is becoming even more difficult to detect or even see them. You see, the light coming from these galaxies undergoes a shift towards the red end of the electromagnetic spectrum, a system aptly known as redshift. The redshift changes the wavelength of light emitted by celestial bodies, which beams away from us at incredible speeds. By detecting this red color, scientists can uniquely estimate the galaxy's distance and age. In fact, when scientists talk about these distant galaxies, they focus on their age rather than their distance. The researchers describe a galaxy as being from the first few 100 million years after the Big Bang, rather than being located billions of miles from Earth. The reason for this is the expansion of the universe, which creates a moving frame of reference that makes it hard to describe distance efficiently. For example, Maisie's galaxy is said to be 13 billion years old, which means the light from Maisie's galaxy has travelled 13 billion years to get to us. However, if we could see Maisie's galaxy today, it would have moved further away from us because the universe kept on expanding. In short, the light that reaches the Earth from a galaxy does not provide the exact location of a galaxy. The expansion of the universe makes it difficult for us to determine its exact location. Therefore, when we talk about a galaxy, we tend to focus on its age, rather than its distance from the Earth. Maisie's redshift and age were originally calculated using galaxy photometry that examined brightness in images using a limited number of wide-frequency filters. These calculations suggested that the galaxy's redshift is 11.8. However, the Finkelstein and Sears team wanted a more accurate age estimate, so follow-up analysis was done with the James Webb Near-Infrared Spectrograph, NIRSpec, which allowed Finkelstein and his colleagues to investigate the lines plotted in the light data detected by the abortions and emissions of chemical elements at specific wavelengths. This helped them to pinpoint the actual redshift of Maisie's galaxy, which appeared to be 11.4. This means Maisie's galaxy is technically seen more recently in the universe than initially estimated, by a factor of tens of millions of years. However, it is still considered immensely old. The James Webb Space Telescope captured the Maisie's galaxy when it was almost 390 million years after the Big Bang. This impressive age places Maisie's galaxy among the 4 oldest galaxies in the universe that have had their ages confirmed by spectroscopy, a scientific technique that splits light into its component frequencies to better reveal its brightness, heat, and chemical composition. Scientists at the Smithsonian Astrophysical Observatory stated that we are currently witnessing a rise of massive galaxies faster than previously thought. The ages of some of these early galaxies are estimated at tens of millions of years. Although such galaxies do not yet pose problems for leading models of cosmology, they indicate that galactic formation began earlier and proceeded faster than expected in the universe. Scientists had already developed models of what early galaxies looked like, and the data for the JWST has contradicted these models. As soon as the JWST began looking for early galaxies, it found far more of them than anyone had predicted. Not only this, the results showed that these galaxies were much brighter. The brightness of a galaxy can be related to its mass, because its light comes from stars. If you can assume the brightness and mass of a star, you can roughly estimate the mass of a galaxy. Whatever models the astronomers have created up until now have led them to believe that there wasn't enough time for galaxies to get this massive in such a short time. However, according to the data received by the JWST, these galaxies are separated into 2 types, spiral and elliptical. It was believed by scientists that the galaxies were too young to develop like the galaxies we see in our local universe. The structures and brightness of these galaxies have led astrologers to question the age of the universe. Some of them have even stated that the universe might roughly be twice as old as they previously believed. They have pushed the age of the universe from 13.8 billion years to roughly 26.7 billion years. However, we do not have much evidence at hand to consider this statement true. In the world of cosmic exploration, the James Webb Space Telescope has changed the way we perceive the universe and shattered our years-old notions of space and time. The James Webb Space Telescope will redefine our understanding of the universe in decades to come, creating new ways of space exploration. The journey into the unknown has just begun, and such promising discoveries will help us reshape our know-how of the universe in the future. So, what are your views about these discoveries? Let us know in the comments below. If you have reached this far, like this video, subscribe to our channel, and click the bell icon so you never miss any of our future updates. See you in the next video. Until then, take care.